Chapter 3 begins with vector-valued functions. These are going to look a lot like vectors, only instead of having just one value in the x, the y, the z spot, you could have a function with any number of different things based upon what a given value is. Here they're using t as the letter of the function, so our value of t. Now if you look here, we get r of t equals, so the function r of t, which is a vector, equals function f of t times our standard vector I plus g of t times the vector j. And similarly, if you've got an x, y, z coordinate, then our r of t is going to have f of t times the vector I plus g of t times j plus h of t times the vector k. And the component form is down below that as well. So in place of one value, you're going to get the entire function of t. Now you typically won't write f of t, you'll write whatever that function is. So let's do a couple problems from the suggested homework. Problem number 1, we're given the functions x is f of t and y is g of t. And it says for the vector valued functions, r of t equals this 3 secant t times the vector I plus 2 tangent of t times the vector j. And they want us to give it to them in component form. Well, that just means that, f of t is equal to 3 secant of t, and g of t is equal to 2 tangent of t. So that means our component form will equal 3 secant and 2 tangent. The next problem, we get 3 different parts. So we're given this r of t is equal to essentially the same thing we have from part 1. We want to evaluate this at these 3 points. So for part A, we want r of pi by 4. So we've got our different values there. Wherever we see the t, we're going to plug in pi by 4. So this is equal to 3 secant of pi by 4 plus, I, the vector I, plus 2 tangent of that pi by 4 times the vector j. Well, secant is 1 over cosine, and cosine of pi by 4 is root 2 over 2, so this is going to be equal to 3 times root 2, which is 1 over root 2, 1 over root 2 over 2. And tangent of pi by 4 is just 1, because it's sine over cosine, so that's just 2 times 1j. So here we have 3 root 2i plus 2j. And that's how we would evaluate that. All right, so let's try it again with pi and then pi by 2. So again, we're going to substitute in pi wherever we see the t. Okay, and so again, secant is 1 over our cosine. The cosine at pi is -1, so 1 over -1 is still -1, so that's 3 times -1i. And tangent at pi is just going to be 0, so that's 2 times 0j. So this is just -3i. And finally, let's do part C. So this is 3 secant of pi by 2, I plus 2 tangents pi by 2 j. All right, so our cosine at pi by 2 is 0, so we're going to have 1 over 0, which is going to be a problem, and the same thing, the tangent's undefined, so this entire thing is undefined.